So after you take this course, you should be able to use the Genero Studio development environment effectively. Genero Studio is our graphical integrated developer environment, our IDE, that we provide with Genero. You should be able to read, write. We will talk about the Genero Interactive Debugger some this week. It's not really part of the class curriculum, but I use that debugger a lot to analyze code that I haven't looked at in a long time or code that I didn't write myself. And it's a quick, easy way to kind of see what an unfamiliar application does. So that's what I use it a lot for. In addition, of course, to debugging problems, which is its main purpose, I use it for two things. One, kind of analyzing an application that I don't know anything about to see where it goes and what it does, and also for debugging purposes, as you would expect. So we'll learn a bit about the debugger, and I've even got kind of an optional lab for that if you want to try to walk through a debugger session yourself to get familiar with it. So we'll be working with BDL code that interacts with a database. So in this class you'll learn to read, write, compile your own BDL code that interacts with a database and can do maintenance functions on a database table like add, update, or delete data. We'll create a basic form and use it in our program. We'll be tinkering with forms quite a bit in this class, and we'll even work with special Genero classes and methods that you can use to interact with the user interface dynamically while the application's running. So we'll learn about what we call the abstract user interface this morning and how using this abstraction enables us to go in and actually touch different components of the user interface while the application's up and running. Towards the end of the week, we'll also be working with single table applications. We'll be doing that all week as we go along, but towards the end of the week we'll get into master detail applications and how to kind of quickly and easily create a master detail form for that application. We have kind of a special wizard that we can use to add elements to a form for master detail applications. So here's our table of contents, so to speak, for the week. We have 12 chapters that we're going to get through. We'll spend, about an hour, maybe an hour and a half on each one of these chapters, and we'll cover 2 or 3 of these a day. So today we're going to cover 3 chapters. We're going to do this overview chapter, which is what we're working on now. We've got another overview chapter where we're going to focus on this Genero Studio IDE, that graphical integrated developer environment that we'll be working with all week. And then the third chapter is a nice short chapter that just gets into a bit about the language, what we call BDL. Business Development Language is what the BDL stands for. So we'll talk a bit about the structure of the programming language and get started with just a very simple application. Again, the main purpose of today is to make sure that everybody has a working environment and is able to do at least a simple application, compile it, and run it. We'll talk about databases and communicating with databases and get into a bit more complex applications tomorrow. So for the first day, we'll probably meet around 2 to 2.5 hours. So today, again, we've got the Genero overview and the Genero Studio overview. And if that runs a bit long because of some of the introductory things we're talking about this morning, we may take a break before we finish Module 2. But a 10 or 15-minute break probably in there somewhere. And then Module 3 is fairly short, where we get into just a kind of introduction of the language. Okay, so a good place to start is, what is BDL? And BDL is just kind of an acronym. We have a lot of acronyms in every software company, it seems like. So this is one of our acronyms. BDL stands for Business Development Language. So just from the name, you can tell it's designed for business type applications, which are kind of characterized by lots of screens and reports, lots of reusable code, things like queries for databases, database maintenance functions, that type of thing. Database interaction in general is kind of a main component of a business type language. So one of the features of Genero, or one of the things we kind of take pride in, is we have lots of features built into the language to facilitate working with business type applications. Things like utilities or wizards that you can use to create forms or apps to interact with databases without a lot of work. So we'll be familiar with those. We'll see some of these wizards, for example, that I'm talking about as we go through class this week. Not today, but we'll get into them a little bit on probably Wednesday and Thursday. It's easy to learn. It's very English-like. It has simple syntax, so programmers pick up on the language pretty quickly. And once they pick up on the language, the development is usually very fast compared to some of the other languages out there. And in addition to development being fast compared to other languages, it also comes with a lower error rate than most of the other tools out there. So that's a pretty good combination. So quick development, simple syntax, low errors. It's portable and flexible to deploy. Something we'll focus on this morning is all the components of the user interface. All the stuff the user sees on the screen are all XML-based nodes that resemble a tree of information. And we refer to that as the AUI tree, or Abstract User Interface Tree. And that tree, that Abstract User Interface tree, gets sent to the client. And we have different types of clients. We have a desktop client and a web client where you use a browser. And then that client, desktop client or browser, gets that tree and any raw data as well with the application, and then just kind of interprets or translates that tree, that XML tree, according to the rules of that front end. So very portable, flexible deployment, and you can pretty much use the same code, compile the code, run it on pretty much any operating system or any client, desktop client or web-based client, without having to make any changes to the code or even recompiling the code. So that's some of the benefits to the business development language. Very flexible, very portable. So here's just a kind of going back to that idea that it's easy to learn. It has simple syntax, which in turn creates a lower error rate than a lot of the other tools out there. It's hard to benchmark application development environments. It's not like, I know a lot of you said you were familiar with databases, Oracle or Informix databases. And I remember when I worked at Informix, there was always benchmarks going on. Databases are easy to benchmark. You come up with some applications, you test running these applications. We had different kinds of benchmarks, for example, like the old TPC benchmarks, and you could just compare apples to apples between like two different databases, Oracle or Informix, for example. So they were simple to benchmark. It's not as easy to benchmark application development environments, but one of our larger customers, this Institute of Social Security Services for Civil Servants, it's got a long name there, but one of our customers using this Carnegie Mellon engineering methodology was able to measure the productivity of several of their development teams across multiple projects using a variety of development tools, as you can see in the slide there. We had .NET, Java, C++, and of course Genero at the top. So they used this methodology to analyze how productive their developers were using these different tools, and this is the results they came up with. This column, this productivity, it's lines of code per hour in this column, and then over here, of course, is the error rate associated with that development. So notice Genero has a really high lines of code per hour number compared to these other tools, almost 12 lines of code per hour. So it's not quite twice, or maybe it is, it's about twice the lines of code per hour compared to some of these other tools. And notice at the same time, even though development is faster, we also have a lower error rate over here for Genero versus the other tools. And again, the reason for that is because of the English-like simple syntax. It's pretty easy to understand, pretty easy to code in, and pretty easy to debug. So productivity goes up accordingly. So there we've got almost twice as many lines of code per hour for these development projects that they were benchmarking, and at the same time a lot fewer bugs, like 70 to 90% fewer bugs or errors compared to the other products. So a bit more about Genero in general. So we have some built-in classes and methods. We're going to be looking at those on Friday. Now before Friday gets here, we'll be looking at some of the specific classes and methods that we'll be using to interact with the user interface or manipulate the user interface. But just for right now, just be aware there's a lot of these built-in classes, which just means they're part of our runtime system. You don't have to do anything special to use these classes or methods. You don't have to import them, for example. So we've got classes with methods to interface with programs, files, pipes, and strings. We've got lots of methods out there to manipulate the user interface. We'll see a lot of those this week. We've got classes with methods to read and write XML. Since our whole user interface is based on XML, we have classes and methods that you can use to work with XML, read or write XML, and manipulate objects in the DOM tree. So that abstract user interface that we're talking about is essentially a DOM document, right? And all the components of the user interface are just nodes in the DOM tree, what we refer to as the abstract user interface tree, or AUI tree. We also have, in addition to these built-in classes that are part of the runtime system, we also have some utility functions and extensions that you can use. They're considered utility functions because they're external to the runtime system. They're not part of the runtime system. So to use these utility functions and extensions, you have that additional step of having to import these utility functions and extensions before you can use them. So we'll see some of that too. But we've got utility functions to do handy things like display an interactive message box. So that just keeps you from having to write that from scratch. You just use this utility function, send it some information that you want displayed in the interactive message box, and you're done, right? You don't have to write that from scratch. And we've got similar type things with database utility functions. So there's a couple of examples of utility functions. We also have C extensions that allow you to integrate your own C libraries. Those are implemented with shared libraries, in case you're curious about that. And now, I think starting with Genero 2.30, I won't swear to that, but we've had the Java interface or the Java bridge for a couple of versions now. You can also import Java classes that you can instantiate in your BDL programs with what we call sometimes the Java bridge or the Java interface. And more recently, we have utilities for JSON. So we support JSON with your BDL code. And I think that was just the last version or so, 2.50 and above. We support embedding JSON in your code. We have an additional slide on JSON if you're not that familiar with it. It stands for JavaScript Object Notation. The whole idea for JSON is it provides kind of a standardized, simple way to parse and serialize data objects to transfer in between, like, for example, a web server and an application on the web. Right? So we can bundle up the data in this JSON format, send it to the server, and then the server turns around and sends data back to, let's say, the web browser or client, and it's also in this special JSON format. So all the modern languages embed JSON parsing and serialization, like JavaScript, Java, and so on. And then starting with Genero 2.50, Genero also supports embedded JSON parsing and serialization. We have a special JSON package, And we've got classes that have methods to convert program variables to and from JSON, handle JSON objects and JSON arrays. We also support web component integration with Genero. We've had that for 2 or 3 versions. I think that was also started with 2.30. That was a pretty big release for us. We had a lot of nifty new features in 2.30, and web component integration was one of those. So a web component is essentially a third-party widget or a third-party technology that might have some kind of graphical functionality that you really want embedded in your application. Something like charts or graphs, maybe some kind of monitoring utility that's graphical. And it doesn't come as part of Genero, but if you can find it out there on the internet, there's a lot of these third-party web components available. Some are free, some are licensed, so you have to be kind of careful about picking those because some are fairly expensive, but you can integrate those into your form essentially as a graphical component using a special form type. It's actually called a web component widget, right? So we have a form type just for web components, and that's how you kind of embed or integrate these third-party web components into your Genero application. So these web components can run on either of our basic clients, the desktop client or the web client. The center of the Genero architecture is what we call the DVM, or Dynamic Virtual Machine. So you can see that right here in the middle, appropriately enough. So the DVM is kind of like a mini operating system, and it's the part of our architecture that actually executes the code that's been abstracted from the presentation, data, and network layers. Now the DVM is kind of like a mini operating system in that it has the whole environment and everything you need to communicate with the database side of things, right? So the DVM gets all that information, everything it needs to communicate with Oracle or Informix from your configuration. It has everything it needs to be able to talk to web services, if you have web services added to your application, and it has all the information it needs to communicate with the front end you're using, operating system, the client you're using from that end. So very similar to a mini operating system, which is why sometimes we call the DVM the runtime system. And when the DVM or the runtime system connects with a client, like a browser or the desktop client, it's communicating the user interface, that abstract user interface we talked about, and all the components of that user interface as a tree of information, right? Just a bunch of XML-based nodes that look like a tree. And this tree is sent to the client, and then the client interprets that user interface tree according to the rules of whatever front end you're using. So it's going to have a bit of a different look and feel depending on whether that front end is Linux or Windows or Mac. And of course it's also going to have a bit of a different look and feel based on the rules for the particular client you're using, whether it's the desktop client or a browser that you're using. So that's how it works. It just sends this abstract user interface tree that has all the pieces and parts, all the components of the front end as XML nodes. And then that XML gets interpreted by the front end based on the rules of that front end. So a bit here about the database part. We just mentioned that the DVM has when you start an application, the DVM gathers all the information it needs to communicate with the database, the front end, and so on. So for the database side of things, which is what we're focusing on here, it's database agnostic. That means that it really doesn't care which database it's communicating with. It communicates with the database using something called the ODI, or Open Database Interface. So that's a Genero ODI, and that ODI uses native drivers. And if you write portable SQL code, right, we also support embedded SQL in the BDL language, and if you do just the smallest things to make sure that your SQL is generic. It doesn't have any, let's say, statements in there that are proprietary to a particular database vendor. For example, Informix has some proprietary statements or parts of statements. And if you write portable code, that same Genero program, without any changes, can open database connections to any of the supported databases. And you can see a pretty good list of all the supported databases right here. Oracle, Sybase, Informix, MySQL, SQLite, of course, is in there somewhere, DB2, and so on. So that same application can connect to different databases without any changes to the code, and it can even open more than one database connection in the same application to different databases, right, and read from all the databases. You configure your database connection information outside of the application, and we have configuration files for that we'll talk about tomorrow. And then just depending on how you change that configuration, it'll open up a connection to a different database next time. Right? So it's very easy to switch between database vendors because of the way that we communicate with the database server. It's all external to the application, and this open database interface actually maps the SQL embedded in the code to the database that we have configured. Now, each one of these database servers we have a special adaptation guide for. So if you have any curiosities, let's say you've been using an Oracle database and now maybe some other company has purchased your company and they want you to move to Informix or vice versa. If you're wondering whether or not the code is portable or how this open database interface will translate these SQL statements from one database vendor to a different database vendor, you can see this adaptation guide, and it will tell you which statements are not portable, right? If there's any proprietary statements, it'll tell you how those are handled, and in most cases it will handle them some way on its own, right? It's all done by the ODI. But in a few cases, there's some statements out there that are not portable and may actually create an error. So we'll talk about that a bit more tomorrow when we get into the database chapter. So for right now, just be aware that the BDL Genero is database agnostic. We communicate with the databases using this special interface called the ODI, or Open Database Interface, and it uses native drivers to map these SQL statements in your code to the database that you have configured for it to use. And here it's talking about the separation of business logic and the user interface. We just got through talking about this whole concept of abstraction, right? The abstract user interface is just a tree-type structure with a bunch of XML nodes in it that represent each component of the user interface. And then it sends that AUI tree, that abstract user interface tree, to the front end, and in the front end and our client renders that tree according to its own rules. And so that's really kind of what we're seeing here in this slide. You can see that here we've got the desktop client represented here on the left-hand side. And you can see that the same application looks a bit different here on the desktop client than it would on a browser, right? So over here we've got two different renditions of the web client, right? So one of them is maybe a browser here running on a PC, software as a service model there it's saying, and then over here we're just using a mobile device like an iPhone, for example. But the web client can deliver an application to anything with a browser. Now notice the desktop, we call that the GDC, Genero Desktop Client, that is supported for Windows, Mac, and Linux, right? Those three different operating systems. And the web client, I mentioned a minute ago, is supported for pretty much any device with a browser. Now this is kind of interesting. This is showing you, you can see a visual of the abstract user interface tree by using what we call the debug tree. It's a function of the Genero desktop client, and now you can actually use it with the web client as well. Let me just show you that. Let's see, I think that's the right one. So when you install Genero Studio, one of the things that you'll get is a bunch of tutorials and samples. So we'll take a look at Genero Studio in the next chapter, but all I've done here is brought up Genero Studio, and then here in our welcome page that comes up when you bring it up, I've got all these different samples and demos here. And I've just picked this one here called Office Store. I just clicked on it, and that brings it up over here in my project view. That's what this area on the left is called. So here's this account application that's part of this Office Store project. And I'm just going to run that. Popped up over here on my other monitor. So here it is. This is this accounts application. And while I'm running that accounts application, I can just control right click, right? Use the control key and right click, and that brings up what we call this debug tree that we're talking about in this slide. Let me put them side by side so you can see a bit better. So all of the components or elements of this user interface here, this accounts form, is represented here in this abstract user interface tree. Because it's nice because you can see exactly where everything's coming from. So that's the reason I call it a debug tree. If you're not seeing what you expect to see, you can kind of analyze that with this special control right click option. But one of the neat things about it is all the components, you can click on them, and as you click on each component of the user interface in the tree structure over here in this debug tree, it'll flash over here on the actual form. So the window, showing me the window component of the user interface. Here's the form, and then I can drill down into the nitty-gritty components. There's a label, there's a form field, and so on. Now this is read-only, by the way, this debug tree. You can't actually, like, let's say I wanted to change the font or the background color here in this form that the user's looking at. I can't do that by going over here and changing these properties. These are read-only properties over here. And like we said, it's just for typically debugging purposes or to analyze what actually is going on in your application, in your form. So that's the debug tree. It's kind of a nifty way. For example, later we'll be talking about things like styles, and you can create your own styles file and affect what the user interface looks like by creating special styles to standardize the look and feel of certain components of the user interface. So when you do that, well, let's say you create your style file and you've got some special font you're using or something along that nature, and then you run the application, but it doesn't look like you expected it to look, you can use this debug tree and actually see if it's really using your style file and what the settings really are that it's using. So that's why it's a good debugging tool. And here again, another explanation of the abstract user interface and how everything about the user interface is essentially compiled down to XML and rendered as XML. So this code that you see here is actually XML from compiling a form file. So we created a form file, you compile it, and when you compile it, it's compiled to XML. And then when you run the application, that form, that node representing the form, is loaded into memory and becomes part of the DOM, right, the DOM tree for the user interface. So the abstract user interface is really just basically a DOM document. So you can see here that depending on what operating system you're using, remember this abstract user interface is interpreted based on the rules of whatever front end you're using, and it's going to look a bit different depending on whether you're working with Windows or Mac or Linux, because it's interpreted by the front end. So that makes it flexible and portable, that part we were talking about earlier on. But this is talking about the architecture again, and how it's versatile and cloud ready, secure and scalable. And it's got a component here that we haven't talked about yet. We talked about the DVM, right? The runtime system is kind of the center of the architecture, but we also have a component we call the GAS, or the Genero Application Server. So the Genero Application Server, or GAS, that you see right here in the middle, is just an engine that delivers an application. So it's the part that creates a relationship between our front ends, like our desktop client and web client that we talked about on the previous slide, to the DVM. So it kind of creates a relationship between the front end and the runtime system. So it also manages all the DVMs, right? The part of the GAS that creates that connection manages that connection and cleans up after a session is over. All that good stuff, the cleanup part. One thing that's important to notice here is that for a deployed application, right, when you're ready to deploy your application and use it in production, it requires a web server. So that's why we see the web server here. The user, let's say, enters a URI, and then the web server maps that or sends that to the GAS, and then the GAS takes over from there and starts up a session, or DVM session, to manage that application. So for deployment purposes, a web server is required. Now for development purposes, I think we'll see that maybe, we don't see that here yet, but for development purposes, you can actually do without the web server, because the GAS has something called a GAS standalone. And I think we'll see that probably in the next chapter, where you can actually use just the local GAS abilities to create a session with the DVM using HTTP. So for development purposes, you don't have to have a web server. You can use what we call the GAS standalone or HTTP dispatch. But once you're ready to actually deploy your application using an application server, you do have the web server requirement. There we go. Okay, so I mentioned earlier in the introduction that Genero Studio is the Genero Graphical Integrated Developer Environment, kind of a long-winded term, and that's your programming environment. Just about anything you can think of that you would need to do to write an application or create a project can be done inside of Genero Studio. So you can write your code, you can debug your code, you can compile and execute your code all from within Genero Studio. We can design our forms, our user interface forms from within Genero Studio. We've got some really nice tools to make that simpler in Genero Studios. Just to kind of go through some of these bullet points on the slide real quickly. Some of these we'll look at this week and some of them we won't. We'll certainly look at Code Editor. We have a Code Editor tool in Genero Studio that you can use to write your code and debug your code. We'll get a good look at that here in just a few minutes. We've got Form Designer that we can use to design our forms, our user interface for the users. We've got Project Manager, or the project view, that we can use to create new projects and manage all the applications and files in a project and organize them. We've got the Graphical Debugger that I mentioned earlier that we'll take a look at this week, even though it's not really an official part of this class. I always like to try to show that one day, kind of in the middle of the week. We've got something we call BAM, Business Application Modeling, that has an application generator, and along with that, here's the modeler. These two components kind of come together. All right, so we have an application generator, and the business application modeler is part of that, where you can kind of graphically design an application and create forms and whatnot, and create relationships between applications and forms and other forms, and actually have it generate that code for you with the application generator. And over here we've got Report Designer. And Report Designer, kind of similar to Form Designer, except of course it's to design your report formats. We've got some wizards over here that help you add web services to your application without having to be an expert on web services. We have wizards for that with this component. We can use a version control system from within Genero Studio so that we can work in teams or development teams. There's a profiler that you can use. We actually talk about this in the other class, the slightly more advanced class that I mentioned earlier. The profiler will tell you where your bottlenecks are. You can kind of think of it like that. If you've got an application that seems to be running a bit long, you can run it and use this profiler, and it will show you in great detail exactly where that application is spending all of its time, right? The percentage of time it's spending in each one of your functions and that type of thing. We'll be working with the database meta schema this week, starting tomorrow. We'll take a look at that. Now the database meta schema we're talking about here is a different meta schema than the ones that you database folks are familiar with. When I think of a meta schema or a schema, I'm thinking of the schema that works with Oracle or the schema that's used with Informix. Well, this is an additional schema just for Genero. So Genero uses its own meta schema for compiles, right? So it actually uses the meta schema for compiles instead of actually having to go out and hit the actual real database. So it's good for performance to use this meta schema. And in addition to that, you can kind of enhance the Genero meta schema, create default values. You can specify what you want the labels for all the database fields to be when you create a form, so that you don't have to go in and change those labels every time. So let's say you've got a field or a column in the database called video num, maybe video ID, v_ID. Well, that's not really what you want the user to see. You maybe want to have it say video number, right, all spelled out nicely. Well, with this Genero meta schema, you can actually go in and specify what you want the label to look like for all the database columns, and then from now on, when you build a new form, it'll automatically pick that up from this kind of doctored schema. So you can add enhancements to it. All right, so that's we'll get into that in much more detail tomorrow, how to work with the Genero meta schema and exactly what it's used for. Then there's a graphical differential that comes with Genero Studio, this last one here in the corner, that's very handy for, let's say you're working with a big source file or multiple big source files, and you've made some changes to it. It's not working correctly anymore. You're not sure what you've done because maybe you've made lots of changes to that file. And you can use this graphical differential to compare the source that you have now with the source from a saved file. And the default for that, unless you're using a version control system of some sort, the default is just the file as it was when you opened it, right? So you get to see it before and after. So you can actually see what the code looked like before you made your changes, and you can even click on it, right-click on the changes, and revert it back to the way it used to be. It's copy to write, it's called. And I might get a chance to show you that here after a while, certainly later today. So a very handy tool for when you're in the middle of coding and you've done something wrong, you can't figure out what it is, this thing will find it for you, right? It'll show you all the changes you've made, and they're easy to see and fix. All right, so those are all different components that come with Genero Studio. So one of the first things you'll do when you get ready to install Genero Studio is figure out how you're going to be using it. So you can install Genero Studio as a standalone tool, and that's what they're calling here local or standalone mode. That's what I'm using this week, and probably what you're using this week. All the pieces and parts of my project are maybe going to be on one machine. Now there's a couple of variations even in local mode. For example, let's say that I'm going to have Genero Studio, I'm going to have all my Genero application server, the BDL, the compiler, the runtime, all of that's going to be on my local PC that I'm working on. But perhaps the database that I'm working with is on a remote database server. That can still be local mode, right? I just have to configure my connection to the remote database server. But the studio components are still local, right? Everything I need according to Genero is on one machine. It's just maybe the database server on a different machine. And there's another couple of variations to that we'll see in just a minute. But local mode, you use that when you want to use Genero on your local machine. You're going to compile, link, run, debug, everything on this local machine. So you just install the complete Genero suite on your local machine. And again, if the database is on a separate system, that's not a problem, right? You're just going to configure a connection to that remote database server. The other option when you're using Genero Studio is to install it in client-server mode or a remote installation. So in that case, you really have two installations. You have what we call Genero Studio Server on one machine. That's going to be your remote server. And then you're going to have Genero Studio Client, which is just plain old Genero Studio without the server stuff activated, on your local machine, maybe your laptop, for example. And then you're going to configure the connectivity information for your Genero Studio Client to be able to connect to the Genero Studio server on that remote machine. Now that's a configuration you'd probably have when you're working with teams, right? You'd probably have Genero Studio Server on a remote server, and that's where all of your other Genero components would be. Your runtime, for example. Maybe your application server would be there. It could even be on yet another machine, by the way. But let's say all of your other Genero components are on this remote server, and that's where you'll have your Studio server installed as well. So you can use that if you're a Genero installation. That'd be your runtime, right? Maybe your application server, all your other Genero components like your BDL language is installed on this other machine. And then you'll need to install Studio on your local machine, like in my case on my laptop, and then I just have to configure my laptop Genero Studio installation to connect to the remote Studio server that's on this other machine. So it sounds very complicated, but it's really not all that complicated. Basically, when you do the install, it asks you if you want to do a server install or a local install, and you just follow the prompts. Then when you configure your machine, let's say my local machine here on my laptop, I'm going to go in and configure the Genero host machine that the remote server is on, and then I can configure that with my connection. Okay, so here's just a couple of diagrams that demonstrate that more visually than how I just explained it. But here we're looking at local mode, and I mentioned earlier there's a couple of variations even with local mode. So here's what I've got, right? Right now I'm sitting here in front of my laptop and I've got this configuration on the left. So I've got all the Genero components, the entire Genero suite, Genero Studio suite installed on my laptop. So I've got Genero Studio, I've got the runtime, which remembers the DVM is also called the runtime. I've got my client, GDC, GWC is installed locally on this machine. And something I forgot to mention earlier, GDC is separate software, right? So I have to actually have Genero desktop client software installed on my client machines to use it. The GWC is actually part of the GAS installation. So when you install the Genero application server, it provides the Genero web client component with that. So that comes as part of the application server install. GDC, though, is a separate install. If you think about it, the GWC doesn't need to be on your actual client machine. So if I've got my end users, let's say I've got an end user here in Dallas and an end user in Charleston, they don't have to have any special software on their machine to use the web client. All they need is a browser, right? So for the web client, they just need a browser, but if they want to use the desktop client, then you're going to have to install a copy of the Genero desktop client on their local machine. I just wanted to clarify that before we got too far. All right, I forgot all about that when we were talking about the GAS, the application server, a couple of slides ago. All right, so on my machine I've got the database. I'm just using a little SQLite database installation here that comes with Genero Studio or Genero. and then my database client software, in addition, for SQLite has come with it. Now for the other database servers, right, like let's say you're working with Oracle or Informix or one of the other database servers, you will need to install the database client on your local machine if you want to be able to connect to the database server. So that will be an additional installation. Okay, now here's another variation of local mode that I mentioned part of, right? The database server does not have to be on my local machine. The database server could be on a different machine, a remote server, and I just need to configure a connection to that remote database server. In addition to that, the source files may be on a remote system. So if I'm using some sort of source control management system, version control software, they're saying VCS up here, then the actual source files may be on a different machine, and I just need to make sure that I've got a network drive configured if I'm working with Windows, for example, or Samba, depending on what operating system I'm working with, so that I can access those source files on that remote machine. Might be on a different system. So those are both versions of our slightly different versions of local mode. The main thing about local mode, I guess, to be aware of is all the Genero components are all local on the same machine. But the database server, the actual source files, can be remote, and it's still considered local mode. Here's remote mode, just so you can see the contrast between the two. So with remote mode, I mentioned a minute ago that you would have two components for Genero Studio. You're going to have the Studio server that's going to be installed on your remote server, and then you'll also have what we're calling the Genero Studio client. It's really just Genero Studio, but you don't pick the options to make it a standalone server. So it's the same software, just slightly different configuration. On the server, you'd have your Studio server, you'd have all your other Genero components on that remote server, like your BDL compiler, the DVM runtime that we've been talking about. Your database server and database client could be on the Genero Studio server machine, or again, they could be on yet another machine, right, a remote database server that's separate. So that's what all of this is talking about. The database server doesn't have to be there. Same thing for the source files. The source files might be on the same system as the Genero Studio server, or they could be on yet another remote server and just be configured, right? The server or your client and the server could be configured to access that remote directory through NFS or Samba, depending on what operating system you're working with. Now on the client side, this is your developer we're talking about here. Your developer side, you'd need Genero Studio configured, installed and configured to connect to that remote Genero Studio server. If you want to work with the Genero desktop client, you'll need to have GDC installed, or a browser if you're just going to be working with the web client. We recommend using SSH for connections between the Studio client and the Studio server for security purposes. So you'd need the SSH server configured on the server, which I forgot to mention over here, and you would also need an SSH client on your client machine, your developer machine. Notice that since we like for you to have that, we actually provide the SSH client for you with your Studio installation. And then configured access to the remote drive where your source files are, and configured access to your Genero Studio server as well. So here are some client options, and I'll just kind of demo some of these here in just a minute. So I'll run through the slides pretty quickly, and then we'll just take a look. And if you've already got your Genero Studio installation done, you can kind of follow along if you like, if you haven't had a chance to work with it before. So down here in the bottom right-hand corner is where you can switch between our different clients. Now the default is the desktop client when you do an install that includes the desktop client, but right down here is the web client. And then in this case we've got some additional clients for we're working with mobile development, like here's one for Android, for example. We've got one here for iOS and so on. But for class purposes, we'll just talk about the desktop client and the web client here. So we've got two different options for the client, and we can just switch between those once we've installed and configured and try out our application on the web client and try it on a desktop client, see if it looks like we want it to look, has the right look and feel. So I mentioned earlier that when you install Genero Studio, you'll get a welcome page. We see that here. And in that welcome page, you've got some sample projects. You have some tutorials and samples here. There's a support interface and some news. So we're going to focus on tutorials and samples and projects. If you click on tutorials and samples, that's where you'll find this Office Store application. Show you real live. So there I've clicked on tutorials and samples, and then right down here in samples and demos we've got all these different options. So if I just click on the Office Store demo project, it brings it up over here in what we call our project view. And these, I'm going to go through all of these nodes here in just a minute. Notice it creates kind of a tree structure in the project view of all of our project files, all the different types of project files. So right up here is our project itself, and this one's just called officestore.4pw. There's actually a file that ends with a .4pw, and this file's responsibility is to track all the other nodes and files and libraries, their location, their properties, all the information about the components of your project. So that's the purpose of this .4pw. And then from there, you've got different nodes that just help you get more organized. This is what we call a group node here, this icon at the top. So this Office Store model is a group. And essentially it would be a group of applications and a group of files that are related to a group of applications. For example, the database. So here's the database information. We'll talk more about this in Chapter 4, I believe, tomorrow. This one happens to be what we call a BAM project. Remember earlier we said that one of the components of Genero Studio, Application Generator, or BAM, Business Application Modeler. And this whole application was generated with this application generator. And I can tell that because of this application flow node. This is what they call a library node, this kind of orange folder with the looks like a little green arrow in it. So that's a library node. And I'll just pop that open for a second so you can see this is what application modeling diagram looks like. These are applications over here. These are forms. And these arrows in between are, of course, the relationships between an application and a form. And it kind of specifies, you know, what forms an application will open, and in this form can open additional forms and run reports. So if you're interested in application modeling or BAM, I'd be glad to give you a quick demo of that maybe on Friday. We'll have some extra time on Friday. It's a short day. But this happens to be a generated application. So some of these library nodes that you see here, these orange ones with the green image in the middle, there's one for databases, there's one for all the different forms and pieces and parts of this generated application. And then there's some additional application nodes. These with the disk symbol, I would call it, are application nodes where you can actually run an application. So if I wanted to run the accounts application, I can just right-click on this application node and execute it. So we'll look at more of those options here in just a minute. But right down here, I can pick my client. Might as well take a look at that. Let me pull this up a little bit so you can see it better. Right down here in the corner, notice I'm using a desktop client. So if I run that application right now, that's what it looks like when it's run in the desktop client. If I switch between that and my web client, takes a second to switch over to that configuration, and I run it again, of course it's going to be displayed in a browser. Alright, it popped it up over here. So here's what it looks like when I run it with the web client. So here's talking about configuring the desktop client. We just looked at an application running within the desktop client. There's 3 different ways that the desktop client can communicate with the runtime system, the dynamic virtual machine, or DVM. What I'm using right now is just a local connection. My runtime system, my DVM, is on the same machine, my little laptop, as the client, right? So the DVM's on the same host. The GDC is going to start it as a local application. So that's what I'm using. But you can also connect via the GAS. Remember the application server we talked about in the previous chapter? The DVM in this example, or this version, or variation, is on a remote host, and the GDC is going to start it using the GAS. So that's, we've deployed our applications, and we're using an application server with a web server to deliver our applications to the DVM. And then we have this direct connection mode. The DVM's on a remote host, and the GDC can start it using TCP or SSH. Now, again, we recommend SSH. Anytime you have an option between TCP or SSH, we recommend SSH for security purposes. Now, if you're using a standalone environment like I am, I'm using this local connection right now. Usually the defaults that comes with are perfectly fine, right? It's got, for example, a particular port that it uses by default, and usually that port is just fine. If I don't have something else using that particular port, I just take the defaults. So most cases that works just fine. If you want to configure GDC differently, you can create a new configuration or edit an existing configuration to configure it for a remote host. Let me just show you a little about that. I won't go through the whole thing because it's not really part and parcel of what we're looking at this week, but let me just kind of get you started with where you would go to do that, since we keep talking about that. The first thing you would probably do, let's see, right here. I don't do this real often, so forgive me if I have to stumble around a bit to find the right options. Server connections, right? So if your Genero Studio server is on a remote host, then you'll need to configure a server connection. So this is the tool, the wizard for dialog that you use to do that. You'd go in here and add a Genero server here that has your Genero server installation on it, and you need to go in and fill out all this information, right? Your connection type. Remember we said SSH is the recommended method, and so on. So you would do that, and then anywhere where you see this wrench icon, it's in 2 or 3 different places. I'm just showing you different places. It's here in the toolbar. It's down here in the bottom right-hand corner next to the client configuration options where you can specify a client, and then it's up here in tools. So 3 different places where you can get to this. I'll get to it here since that's the last one I'm showing you. And here's all of your different configurations. Notice right here is the desktop client configuration. The web client configuration was selected because that was the last one I showed you, right? That's the one we have pictured or selected down here in the right-hand corner. And then all of these environment sets are available for this configuration. Notice I could use Informix databases, DB2, Postgres, and I can configure the settings for those. I heard a lot of you are using Oracle, so let me click that, or a couple of you are using Oracle. So right here, if you were trying to connect to an Oracle database, this is where you could configure your Oracle Home, Oracle SID, your path here. I know a couple of you said you're working with Informix. Oh, I passed it already. It's up here at the top, close to the top. So there's where you would specify your Informix server and Informix dir and path environment variables if you wanted to work with Informix. And then for this configuration where you were using that database, you just make sure you had that environment set selected. So getting a bit ahead, but it's a good place to show it to you. So there's your configuration options for desktop client or web client. Desktop client, I can have certain things selected and different things selected for the web client. And then down here, we've got additional options like, go back up to desktop client since that's what we were talking about. Right here, Notice his use display client, and here's my GDC and my version information. Right here I've got an edit option where I can go in and configure or change these details. So I just wanted to show you real quickly. You can get in and configure your GDC settings right there from within Genero Studio options. Okay, let's see what else we have here. So there's talking about configuring GDC. Now, Genero Web Client, here we're talking about configuring the GAS. So to use the web client, you do have to have the application server installed, and you have to have it configured either with a web server, or for development purposes, you can use what we call the GAS standalone, and that's what we're talking about here on this slide. So for development purposes, GAS can provide a direct connection over HTTP to applications so that you don't have to have a web server for development purposes. But once you're finished with development and you're ready to deploy your applications, you are required to have that web server. So let's say you're in development mode and you just want to use this GAS standalone, what we call HTTP dispatch, that's the actual executable name for the standalone GAS. Then essentially you just have to start up the standalone GAS executable, and then the GAS can handle its own HTTP capabilities and serve the web page on its own. So nowadays you really don't even have to know much about that. Now in the older versions of Genero Studio, what we used to do, let me just show you real quickly, and you can still do it this way, is go out to your installation. Like I said, I don't do it very often, but here it is in Tools, right here in Genero Application Server. See how it says, if you look, it says Launch the 4J's Genero Application Server Standalone. So you can do it that way. Just click that option. Another way to do it, and this is typical like on Linux, for example, you can just go out here and open that option that says Genero Workplace Window, and you can just type in HTTP dispatch. And that's the same thing. Now I'm already running it, so I'm not going to run it there, but that would work just as well. So just to show you, this is my task manager, and there it is right there. So that's our GAS standalone we keep talking about. Notice that even in the description it says HTTP dispatcher standalone. So we don't have to have a web server for development purposes because we have this option. Okay, to test that out, they're saying check and make sure your standalone's working okay by testing out the demo applications that come with Genero. So I'm going to do that here, and it says it right there on the slide, but I can just type in, whoops, there we go. I've already run it once, it looks like, in the past. That's right. So if this pops up and I can see this demo application welcome page, that tells me that my standalone GAS is working okay. All right. So these demos, by the way, are really helpful when you're learning Genero and you're looking at language features and anything about the user interface. There's some really good example programs here just for that. Okay. All right, looks like the rest of this is just a tour of Studio. I'll do some of it here in the slides, and the rest of it I'll just show you live with my Studio installation. So here's the welcome page we talked about a few minutes ago that has these sample projects and a tutorial in it. Here's this Office Store sample. I mentioned earlier that this is a generated application, so it's generated with Business Application Modeling, or BAM for short. We call it BAM sometimes. And it has two applications. It has the Accounts application and the Orders application. And for demo purposes, I just showed you the Accounts application. But you can go way down here to the Orders application, down towards the bottom of the project view here, and you can run that Orders application the same way. You just right-click on it and select the Execute option. All right, so let's look at the project view for a few seconds, and we'll just look at it live again. So up here at the top, we talked about every project has a .4pw file. So that's what we see at the very top of the tree structure. So the .4pw is the project file. And I mentioned earlier that its job is to keep track of the organization of your project files, the files that are in your project, and the information about the files, like their name, path, information about them so that it can find them next time. Now remember that this project view is just a logical view. In other words, let's say that I add an application, add a source file to my project view that's out there on disk, and I put it in my project view. And let's say I've saved my project to a file called /myproject, right? d:\myproject. If I add a file to the project here in this project view, it doesn't actually move that file to my project directory. It's just kind of a logical view of the project, but it doesn't move things around. If I delete a file from within my project view, by default it does not delete it from disk. There is an option for that though. Let me show you here. Like let's say I decide I'm going to delete this file here. Notice I have a delete option which just deletes it from the project. It goes away and I don't see it anymore in this library node. But if I click the delete from disk option, it will find that file using the path information stored in the project file, the .4pw, and it will delete it from disk. So you do have to be kind of careful with that. It is a logical view that this delete option can actually delete it off the disk. But these files can be in various places. I might have this source file. Source files, by the way, end with a .4gl. We'll learn about that in the next chapter. And you can see where it is here, right over in the properties view. All these different nodes have their own set of properties that give you information about that node and its contents. Not a whole lot of information for some of these, but when you get down to source files, it's a bit more informative, like file path. This is the actual location of that file. You can specify compiler options so that when it compiles the file, it passes its special compiler options that you might especially need for some step in your application development. You can exclude a file from being compiled. Maybe you just have it in your project for reference purposes so you can go and look at it periodically, but it's not actually a part of your compilation. And you can also exclude a file from being included in the linking process as well. So that might be something you do especially for libraries. If you have external libraries, like an external C library, for example, you'd probably exclude it from compilation and maybe even exclude it from linking process. All right, so back to these nodes. Let me just pop through them real quickly and then I'll come back and explain them better. So at the very top of the tree is our project file itself that's responsible for keeping track of all the nodes and contents of the nodes for this project. This is called a group node up here at the top. So I might have multiple applications and types of applications, and I can logically group them in different groups if I like, if they don't have that much in common and I want to keep them separate. Within a group, then I might have one application or multiple applications like we have here. Right, this one has two applications. I've got an accounts application and an orders application. I'm going to assume that they're related because they're in the same group, right? Same logical group. So here I've got my files that make up this application, or some of the files that make up this application. This one is a source file. I can see that because it ends with a .4gl. All of your source files in Genero, at least all your BDL source files, end with a .4gl suffix or extension. And then here's an XML file. This is a file that's only used with the application generator, by the way, that you see that it's compiled down to XML. And this, again, this PRG is also just used with the application generator. You won't see those this week when we work with creating applications manually. All right, so here's the database node. We'll look at it tomorrow. So I'm just going to kind of leave it at that for today, and we'll get into that tomorrow. Entities is another library node. You'll see that typically with a managed project, which means we're using the application modeler for that. And a lot of these special files that the application modeler uses goes into this entities library. All right, so group nodes, application nodes, and library nodes. Library nodes, typically that's where you would put, like if you had any external libraries, or if you just had even a BDL module that has, let's say, some shared functions in it, you could put that in a library node, for example. Makes it easy to see what it is and to organize everything. So I showed you the project properties. All the different nodes in the project have properties so that you can specify things like compiler options, whether or not you want the module to be excluded from a build or compiled at all. All of that's options here in the project properties, or properties for a given node. So there's different options to create a new project, right? So here we've got Genero desktop project, and then there's a simple project. Let me show you the difference between those. So file, whoops, too quick here. File new, and then under the Genero category over here on the left-hand side, I've got desktop project and simple project. A desktop project, notice if I click on that, it says down here, I'm creating a project to develop desktop applications, and it's going to have some pre-existing file structures. So let me go ahead and do that. I'm just going to create that. When you create a project, you give it a name. So I'm going to call it test, because I'm going to delete it pretty quickly. And then I can browse or specify a path for that. So I don't want to put in there. I created a directory just for this kind of thing this morning. So I'm going to put it in this temp folder. You can't see it very well, but then right down here is an OK. I'm going to click that. And it says, hey, you've already got a project here in the project view that you've modified. What do you want to do with it? Well, when I modified it, I really didn't do anything I wanted to keep. So I'm going to discard all my changes. And there's my new project, right? Test.4pw. And this particular option creates this structure. Right? So I see this structure in my project view. I've got a database maintenance group. I've got a packages group that I can use for deployment. It's got some special, kind of a special structure that makes deployment easier. Creates special structures on disk when I deploy. And then I've got a project group node. So these are all group nodes, right? Database maintenance, packages, and projects are all group nodes just to help me organize. And then in the project group, I've got one application node that comes by default, and then several of these library nodes. Got one for config that has a special file in it called FGL profile that we'll talk about a lot tomorrow. Got a database node that already has an empty database in it called mydatabase.4db. Whoops, sorry, mydatabase.db. That's the actual database. And this .4db is the Genero schema that I was talking about earlier. It has a 4 in it. And then we have an entities node that's just empty because we haven't done anything with our new project. And then we have a resources node that has a default application configuration file for use with the application server. So I can modify that and view that right here within the project. So this is all the different structures you get in the project view when you pick that option, File, New, Desktop Project. So let me show you underneath the covers. These are the different structures that it creates. So it created a config, a database maintenance directory, an images directory, resources, source, and even a web components directory. So this is the structure you get that's got a lot of pre-existing structures out there for a project. Now for class purposes, I'm not going to have you use that. Let me get rid of all that so you can see the difference. Let me close it first. That would be a little tidier, wouldn't it? So there, I've closed it. Now I'm just going to delete all that. But notice all the different folders you have in there that were created when I created that project. Just going to delete it all. And this time I'm going to create a simple project, which is what we'll do in class this week. And it's just an empty project. We're just going to go real simple this week because sometimes having all that organization can be a little confusing when you're brand new to the software. So now I've got another new project. I'm going to save it. I'll call it temp again. Save it, and notice it's very simple. I just have an application node, a group, a database library, and a library, but they're empty, right? There's no pre-existing files in any of them. And if I go and look in the directory structure, all I have is the project file, right? The two project files. But I don't have any pre-existing directories like we do when we use the desktop project option. So I just wanted to show you the difference. So this week we're going to just use the simple project. All your files will just be all dumped into the same directory, so it's easy for you to find things while we're just learning. All right. So that's creating a new project. Whoops. And something to be aware of, but not to worry about, especially at this point, is the idea that there are build rules that Genero Studio has that control how your source files are compiled. You can actually make your own build rules. There's some that pre-exist. The ones you see here in this slide already exist, these default. So in other words, what it's looking at is the MIME type of the files it finds when you do a compile. And let's say it finds a file type that ends with a .4GL extension. So what the compiler is supposed to do with that is compile it according to these rules down here at the bottom. See the build rule details, and the output files are going to go to your target directory, and it's going to have the input base name, which is the name of the file that it's compiling, and then it's going to put a .42m on the end of that file as an extension. So essentially it's just command line options that tell the compiler how to compile files that are a certain type, like a file that ends with a .4GL. Here's a form file that ends with a .4FD. It's going to have different build rules and so on. So all these default build rules, you wouldn't want to change these because these are our standard options, our standard build rules for all the different file types that Genero uses. The .4GLs, the .4FDs, the .PERs, and so on that we'll learn about this week. But if you do have some specific, let's say maybe you're working with other tools, for example, C and whatnot, you can create your own set of build rules and set them up in global, as global build rules right here, or you can even be more specific with specific build rules. And there's even a project level set of build rules. And the priority is it will look for the one with the most specific first when it gets ready to compile some files. So if I have some build rules set up for a specific project, which is down at the bottom of this list, it will use any build rules that apply, right, that have the right extension for the file first from those project level build rules. If there's not any that apply to a file it encounters, like let's say you have a file that ends with a 4xz, right, and you don't have a build rule for a file that ends with a 4xz, then it'll go from the project level build rules to the specific level. So it just works its way up the chain. If you don't have any specific build rules that apply to that file type that ends with a, I forget what I said, ZO, for example, then it'll next look in global rules. If global rules don't have a build rule for that type of file, then it finally goes to the default rules. So the default build rules are the ones that are always there. They're provided by Genero, and then you can create your own build rules for different types of tools that you use, for example, to specify the options, where you want to put the output files, for example, when those files are compiled, and the compiler options you want to use with them. So that's what build rules are. But again, most of the time, especially for class this week, we can just rely on these default build rules for everything we do. All right, code editor. We'll look at code editor as we go through the week, but let me just pop in there real quick and we'll tinker with code editor just a bit. So let's say new file. Oh, first off, notice I'm in my new project, which I have saved. It's called temp.4pw. One thing I probably would always want to do is rename my application. I'm going to call it my app, right? Just to show you can change the names of all these nodes. And then I'm going to create a source file here. I'm going to create a new file, and then I'm going to go down here to Genero, and then there's an option there for source. All the Genero BDL code that we work with is going to be in a .4gl source file. All right, so I'm going to give it a name. I'm going to call it my source and save it to my new directory there that I created earlier. And as soon as I save it, notice it pops it out here and it opens it in Code Editor. So this area right here in the middle is Code Editor. So notice it gives us a nice numbered list there. So every line is numbered. And something else I can see here is notice it's pretty good with syntax, and it's going to tell me if I make a mistake, right? I've already made one. It didn't take me long. It says, hey, you've made a grammatical error. I'm expecting something else here. Now that one's kind of vague because it could be just about anything at this point, but let's say I realize what I've done. I'm going to go down here and do that, right? And so notice that when I fix the error, that error message, that big red X that's over here in the gutter area of the code editor goes ahead and disappears on its own. Now notice also we've got some color coding here. Now right now everything looks orange. Orange is reserved for changes. Well, everything's pretty much a change at this point for this new file. But let's say I save this, and we'll see this later. Save it, and I come back in later, and I add a line here. So let's say I add a display statement. Now, if I had saved this file and came back in, this display statement would be green, right? So it actually would add that line in green. It would be color-coded green, and that way I could just glance at it and know, oh, this is the change I've made today, all these green color-coded areas there on the left-hand side. But I haven't saved this one, so it's just showing up with this generic orange color that it's using right now. So there's Code Editor. Something else you can do, I'm going to pop down here just to show you something. It's got, I guess you could call it coding assistance. That is the proper term, I think. Coding assistance. So if I just use a Control-T right here, it brings up a bunch of templates. So let's say I wanted to add a function. I can just scroll down here. This is Control-T again, and I can just pick function. Double-click on it, and notice it kind of creates the shell for me for a function. It knows that a function needs the function keyword and an end function. Also needs a name, so that's the reason I'm getting this error, right? So, hey, I've got a grammatical error here. It's expecting some other information. But anyway, we'll talk about that in the next chapter, so I'm going to wait on that just a bit. For right now, just be aware that it's got these templates that you can look at with a Control-T. Notice there's a lot of them, like for each loops. Right, so function, oops, that didn't go in the right place because my cursor wasn't in the right place, right? Any number of different options there for Control-T. Even reports have these options. I think I'm just going to get rid of the whole thing at this point. That would be easier than cleaning all that up. All right, so there's a whole list of options here for Code Editor. Notice one thing at the top. It says it's a programming-oriented editor. It handles any kind of text or language. That means that this thing, it knows XML, right? So if I want to go in and edit XML, it's aware of XML proper syntax, right? And it will give me that same kind of, like the red X here in the gutter if I've got a syntax problem with it. So you can use Code Editor with more than just BDL. It has that coding assistance that we saw earlier where you can use the templates with the Control-T and bring up the templates. And it also has like the smart completion. Like if I'm working with, for example, classes and methods, if I specify a class, it's smart enough to show me a list of methods as I'm typing along. And instead of having to remember the method name, I can pick it from a drop-down list. So it's got some really clever clever things built into it that way. All right, so we'll look at Code Editor a lot more as we go through the week here. I've already showed you the coding templates, and I'll show you the auto-completion a bit later. When we start working with program records, you'll see that. You'll also see that with classes and methods. All right, so that's kind of a quick introduction to Genero Studio and a few of the components of Genero Studio. Really just the ones that we're going to be using for the first couple of days. And as we go through each individual chapter this week, we'll see additional Genero Studio components like the debugger. I'll show you that one as well later. So the third chapter is just a quick introduction to the language, Genero BDL, which you remember stands for Business Development Language. So we're going to look at the introductory rules of programming, and in your lab this afternoon you'll have just a very simple application you're going to write just to make sure that you're working around in Genero Studio and are familiar with the project view, can add a source file, compile it, and run it. And if we get all that done, then we're all set for tomorrow. So here we're going to learn how to write, compile, and execute a very simple BDL program. We're going to talk about the variables and constants and the different data types that are supported by BDL in this chapter. All right, so some conventions for Genero Studio. It's just plain text, and you write your plain text in a source module, which we saw earlier, that ends with a .4GL. You can comment your code. You can put as many comments in there as you like. There's a couple of ways that you can make comments. If you're just commenting one line, you can use a couple of minus signs right together, like you see here. Grab my highlighter. Or you can use the pound symbol or hash symbol, whatever you prefer to call that symbol. So either one of those are good for commenting individual lines or a couple of lines of code. You can also use curly braces. So if you have a large area of documentation, like a whole paragraph of stuff that you want to put in to document the use of an application for some sole following later on, you can use the open and close curly braces to delimit a large area. That's a lot easier than using the minus signs or the hash symbol in front of every single line. So that's an easy way to do a bunch of lines. White space. Feel free to use as much white space as you like to make your code more readable. So all white space is just treated as a individual white space. It doesn't care how many spaces you put in there. You're not limited. And you're also not concerned with case with BDL. If you like camel case, like if you like lower and uppercase letters, naming variables or functions or whatever, you're free to use that. If you like to use uppercase for reserved or keywords, you can do that. Or you can use lowercase for everything. So it's entirely up to you whether or not you want to stick with or standardize on a particular case, upper, lower, camel case. In a lot of our sample programs and tutorial, for example, we try to use uppercase for all the reserved words or keywords just so that they're recognizable to new programmers. But it's not required, right? We don't have to put those reserved words in uppercase. All right, simple program structure. We do have a structured programming language, which means that all your executable statements have to be grouped into one or another program block. There's one mandatory program block called main. So every application has to have a main program block, and that's where your application always starts out. Then you can have one or many functions that are part of your application. So we have a function program block as well. And you saw some of this when I was tinkering around with Code Editor, right? We had a main and an end main. And in here we also now have a function and an end function. Notice functions have names. Functions can be passed arguments or parameters. That's what the parentheses is letting us know there. And then you can have any number of lines of code between your function and end function statements. We have one additional type of program block called a report block. We don't get into reports in this particular class, so we're just going to focus on the first two program blocks, the main and the function program blocks. So here's some options in the the project view, I think we've probably seen some of these because I was executing the accounts application a little while ago, so I was using this execute option. These are all context-sensitive menu options that you have in the projects view. If I right-click on an individual application node, I'll get the option to build it or rebuild it or execute it, and a lot of other things here. We saw the rename and the delete a little while ago, so you're familiar with those. I added a file, so you saw that we could add a file to a library node or an application node. We can do that. But applications, we can execute them, build them, rebuild them, or clean them. So let's talk about the difference between those three things. Now notice over here I've got an option to compile too that we're looking at. So for an individual file, it can be a form file, for example, or a source file that ends with a .4gl. If I just want to compile that one file to see if I have any errors in it, I can use that compile file option for that. And it will just simply compile that file to, in this case, a 42M extension. That's our compiled module. If I want to execute an application, I can just use the execute option like we see over here on the left-hand side, and it will automatically check to see if all of the files are already compiled that are part of that application, and if they're not, it will go ahead and compile them and even do the linking for me automatically. So most of the time when you're working with Genero Studio, especially this week, you can just work with the execute option, and it will automatically do any compiling and linking of my application files in my application node before it executes. Now if I have a bug, I might get down to a little deeper level and start trying to compile a file individually that I know I've got some problems with until it compiles properly. Something else I might do is rebuild. If I make some changes to a source file in an application, I can rebuild, and what that will do is clean output files and recompile and link if it needs any updates, right? It will check to see if I've made modifications to a file and recompile it if necessary. If the file is already up to date and it hasn't had any modifications made to it, it doesn't bother recompiling that file or cleaning that file. It just goes ahead and uses it as is. Now the clean option, what that does is actually deletes all the output files associated with the application so that then it does have to be compiled and relinked at that point. So that might all be done in the process of troubleshooting, changing an application, and making sure that all of my changes take effect. All right, so variables and constants. I think most of you have probably had some experience with a programming language of some sort, so most of the time this is not new concepts for most folks in class. So we have variables and constants, and just like the names imply, variables hold data of a specific BDL data type that can change over time. That's why they're called variables. You do have to define them or declare them with the define statement. And a nice shortcut when you're working with databases that is, you can just use the like keyword to declare a variable, and it will automatically look at the schema, the Genero schema, and declare the variable with the same data type as what the database column has in the schema. So that's a nice shortcut. And it also has the benefit that if you go in later and change the database schema and change a data type from, let's say, a small integer to a large integer, for example, or a character to a variable length character, it will actually pick up on that automatically because of this like keyword. So that's kind of a benefit as well. So that inherits settings from the database schema. So here's an example of both. Right here we're defining a variable called action no. And notice we're using camel case here, right? We're using all uppercase, it looks like, for keywords. And then for this variable name, I'm using lowercase and uppercase, camel case, basically. And that is entirely up to you, right? That's just a user preference what case you use. So there's a very simple variable defined as a small integer. And we'll talk about the different data types here shortly. Here's another one using the like keyword because it's a variable that's based on a database column. So it's just going to inherit that data type from the schema. And we'll talk more about schemas tomorrow as well. Now constants, of course, we use the term constants because they don't change. So they're read-only values that are identified by a name like a variable name, except that you use the term constant. So constant, give it a name, specify your data type here. And of course the program cannot change this constant value. It's kind of written in stone, right? Once you define a constant, it is not changeable. So it's a read-only value. You can define structured variables. We have arrays and records that are both considered structured variables. Array, the main difference between the two is that arrays are always groups of items that have the same data type or the same type. And records is an ordered list of variables where each member of the record can be any data type. It can even be another record that you've already created or defined or an array. So records are typically just a hodgepodge of different data types and sizes and even records within records. So they can be kind of complex structures. So here's an example of defining an array. We have two different types of arrays. We'll get into arrays in much more detail later in the week. So for right now, just be aware this is a static array, and I can tell it's static because it has the size defined. So it has a maximum number of elements that I can store in this array because it's static, and if I remember right, it is 65,535, I think. It's a standard number that if you've worked with databases for a while, you're probably familiar with that. So 65,535 elements. The second example of defining an array is different. It's a dynamic array, and you can tell pretty clearly because it actually has the word dynamic. So this is a dynamic array, and it's an array of records, right, defined like a table in the database, product.star. So that's a fairly complicated looking array there, right? It's an array full of records that have been defined like a database table. But every one of those elements in the array have that same structure, right? They're all the same type, which happens to be a record with defined members. All right, so more on arrays a little bit later. We'll talk about the big differences and the benefits of using dynamic arrays over static arrays in another chapter. So another type of structured variable that you can work with is a record, which we just talked about. But a record is an ordered set of variables that can be any data type. It can even be a record with other records in it or an array as part of the record. So here's an example of a record that has a ID, a variable called ID, that's an integer. It has another member of the record called name, that's a varchar, a variable length character member, the maximum size of 50, and that's it. Sorry, here's the end record. Notice records have to be defined with the define and an end record. Defined record, end record. And here's our shortcut, define R1 record like account. So this one's like account.star. So we talked about earlier, if you use that like keyword, it can go out there and pick that up from the database schema. So it will figure out exactly what members it needs and what data types those members should have. And finally, user types are interesting because with a user type, you can actually create your own data type. That's what a user type is. But you're not really creating something from scratch per se. What you're usually doing with a user type is you're defining a type that is made up of usually multiple variables and variables from different tables to create essentially a record that is like possibly multiple database tables and columns. It makes it easier to do SQL statements, which we'll look at a bit later on. It's kind of hard to explain right now. So for right now, just think of it as a user type that you define yourself. You can use the like keyword with that user type so that you can define members of this public type like a database column and inherit the data type and the size that way. And you can use regular variables that are not associated with database columns in the same user type. So it's just a hodgepodge of members that might be coming from the like keyword or without the like keyword. So a lot of times it's so that you can set up a select statement and make it real easy to do that in the code. So we'll see examples of this later that will make it more clear. So that's a user type. Once you define your user type, you give it a name like this. When you define it, you can then use that to define variables of that user type. So this one is a variable called mRecAccount_lookup that is a type recAccount BR type. And that's this public type up here with all this hodgepodge of variables of members defined like database table columns. And then you can use that variable in your code just like any other variable. The scope of a variable can be local, modular, or global. So local just means that you can use the variable in the function, report, or main program block where it's defined, right? So it's only known within that one program block. So that's local. The define has to precede any executable statements, so it has to be at the top before you have any executable statements. If you have a variable that's modular in scope, then you can use that variable in any function in a single source file, right? A single module. And again, the define has to appear at the top of the module before any executable code or any program blocks with executable code. And then a global variable can be used in any function in any module of the same program, right? It's pretty common to have applications that have multiple source files that are all compiled and linked together. And a global variable can be set or used in any function in any one of those multiple modules. Now there's a couple of ways to define them. You can use what they call a global block declaration, right? A little area at the top of the application to define them like you would a regular variable, or you can put them in a file by themselves and then import this globals file. So there's two ways that you can define them that way. Just FYI, modern programming practices discourage the use of globals. So instead of using global variables, which are not very readable, the code that uses globals, you have to really search sometimes and look to see where those globals were used. They're not very readable, they're not very modular. So nowadays they recommend using something called a public variable and then importing modules with these public variables defined into a module that can then use these defined variables, these defined public variables. That sounds kind of complicated, but basically all you're doing is defining you can actually have a function that's defined as public or a variable that's defined as public. And once you have these variables defined as public, then that means you can import the module that they're defined in into another module that wants to see those variables or set those variables, and then it has access to them. But they have to be defined as public. So you use the keyword public like you see here, and if it's not defined as public, then it's assumed to be private. So a private variable could not be shared, right, or seen or set by an importing module. Only the public ones. So this is what we prefer to use over globals. We're going to define some variables as public variables, and then in a module where we want to be able to see or set those variables, we use the import statement like you see up here to import the module that has those public variables defined, and then we can use them. You can see a lot of examples of that with the generated code, like that office store project that we were looking at earlier. We ran the accounts application. It uses that methodology a lot. So it has a lot of public variables, and it uses import, like you see here, to import those modules with those public variables instead of using globals. I mentioned earlier, of course, you can pass variables. So variable values can be passed as arguments to a function that's invoked or called. They can be passed as, you can pass literals, right? You just put them in quotes, and you can pass a literal, or you can pass variables, constants, or even expressions. And if you do have multiple arguments when you call a function, you can separate them with commas. So here's a simple example. Here we've got a main program block here, and then we've got an additional function program block down here, just to go back to all of our structures. Here we're defining a variable called a phrase that's set up as a string. The data type's a string, unlimited character data type. And here we're saying let a phrase equal a literal, hello world. So now a phrase, this string, contains the value hello world, and we're calling a function called sayIt, and we're passing it this variable, a phrase. And of course the contents right now, the variable is set to hello world. So here we've called this function. So this function's invoked. Here it's accepting this argument, sayIt phrase, which down here is defined sayIt phrase as a string. So of course it has to be compatible data type with the calling function. And then we're just displaying this sayIt phrase. So you'll be doing a very simple application like that. The very last part of your lab is to create an application just like this, where you're going to pass a value to a function and display it to standard out. This display statement, by the way, just displays to standard out. And standard out for Genero Studio is just the output view. Let me show you that. Right down here, this is our standard out area for Genero Studio. So if I use the display statement, this is where I would look, is in this output view for any display from a display statement. All right, so we're just going to go real quickly through the different BDL data types. The purpose here is not to memorize all of these, but just to give you a general idea of what kind of data types we support and are available for you. So of course we've got all kinds of character data types. We've got a bunch of string data types. We've got character or char. Either one of those works, right? If you just say char to open parentheses 240 close parentheses, that works just as well as spelling out the word character. So these abbreviations are fully supported. So if you don't want to spell the whole thing out, you can just say char. We've got varchars, which are variable length character strings. They still have a maximum size. The very maximum size, the biggest that you can make a varchar, is that 65,534 characters. We have a string data type that doesn't have any kind of maximum. It's just based on the operating system that you're working with. So that's the theoretical limit for it. So variable length, dynamically allocated character string. So characters and varchars have a max size, but strings do not, at least theoretically don't. We have some date data types. We've got a date, which is just a simple calendar date. We have a date time that gives you a high precision date and hour data. So if you want the hours, the minutes, and the seconds, you can use a date time for that. We've also got an interval date data type that has like a span of time that it stores, like a year to month, or day to minute, or day to second type value. You can also use it to store the differences between two mathematical, like a mathematical expression with dates. Like I can subtract two calendar dates and store the result in an interval. And we have a Boolean data type that is just true or false. And our Boolean data type is a true or false 0 or 1. If you've worked with some of the other database products out there, they might support things like Y and N, right? Yes or no. but our data type just evaluates to 0 or 1 is what actually gets stored under the covers. And here's some numeric data types. We've got, I'll just kind of summarize this by saying we've got all the way from big int, which is a ginormous number that has, oh gosh, like 12 or 13 digits in it. It's huge. It's an 8-byte signed integer, all the way down to a tiny int, which is just 1 byte, right? So just about any kind of number that you want to store, any kind of numeric, you ought to be able to find a numeric data type that's suitable for that. We also have several of them that have more precision. We've got float and double precision, which is an 8-byte floating decimal point. We have a small float, or real, which is just a synonym for small float. That's a 4-byte floating point decimal. We have a decimal, which is, I believe, 32. The default is 16 significant digits, so it's very high precision. And in money is the same, 32 for this number of significant digits, but it also allows you to format that, like with a dollar symbol, for example. And then we've got a couple of large data types that are supported. I know a couple of you have worked with Informix or Oracle that supports large data types. Essentially, byte is large binary data. Typically, you'd use this to store like music files or pictures, image files, that type of thing, JPEGs and so on. And then we also have a text data type, which is plain text, to store large text data, contents of a book or something like that. You'd be best off storing with a text. And finally, Genero file extensions. You've seen a few of these now, and you'll see some more of those as the week goes on. I'll start first off up here at the top. So your compiled and linked application that's ready to run is a 42R, right? It'll end with a .42R. We saw earlier that a source file that we type our BDL application code into ends with a .4GL. And when we compile a .4GL file, it ends up with a .42M extension. Down here on this left-hand side, we haven't talked about any of this yet, so this will be kind of new for you if you're new to Genero. We have two different types of form files that we'll talk about a little later in the class. There's the old text-based form files that have been around ever since Genero was created, and they end with a .per. We call them per files sometimes for obvious reasons, right? They end with .per or per. And then nowadays, all the more recent versions of Genero, we have a component of Genero Studio called Form Designer. And when you create a form with Form Designer, it ends with a .4FD, Form Designer extension, right? That's what the FD stands for. But it doesn't matter which type of form you've been working with or prefer. When you compile a form file, it compiles to a .42F. So that is a compiled form file. And then finally, when you've linked in your program, you've compiled everything and you've linked it, then you end up then again with your 42R. That's your runnable, your executable application. So I think that's the last slide for today. It is. Okay, good. But before I let you go or see if you have any questions, let me tell you that you have a lab for today that I would highly recommend you do. It's a real simple lab, and it'll also help to make sure that your environment is set up appropriately and that it works. Here's Lab 1, and Lab 1 is the same lab for modules 1, 2, and 3, all the modules we covered today. So the first exercise is just getting familiar with the help and the documentation. So something just pop into for just a second. We've got this help icon over here. We've got the help menu option up here. I think our help is pretty good. You can do searches. Just search for BDL. And you can overview of Genero BDL, and you can learn all about the Genero language from that and just following the links. This is talking about the abstract user interface and all of the things we talked about earlier today. But in addition to be able to get into help that way and kind of doing a search for what you're looking for, you also have the ability to use context-sensitive help. Like let's say I'm looking at this property area here for my project and I don't know what a compiler option means. What is that? So if I hit F1, highlight something and hit F1, it should bring up my context-sensitive help. Alright, so I just hit F1 and it brought up, and notice that it brought me to this area that's talking about the project manager node properties. So I can go down here and say, oh, compiler options, those are options to be passed to the compiler. For example, a -S to dump static SQL messages. And then it's got additional info in here about whether or not it can be inherited from other nodes in the project, whether it's read-only, the group. It can be set at the group level, application level, library level, and so on. So a lot of good information here about all these different properties, for example, that you see on the right-hand side. Just be aware that the help is nice. You can use F1 or you can just bring down the help from the menu option and do a search. So the next thing we have you do is run an application with the desktop client. And remember, when you do a control right-click on the application screen, it'll bring up that debug tree that shows you all the nodes in the abstract user interface, the DOM structure, basically, the DOM document for your user interface. So you can explore the debug tree. Remember, it's read-only, but it talks about that in the lab, so I don't want to ruin it for you. Let's see. And in exercise 3, you're going to run an application in the browser, use the web client, which our latest version of the web client is called GWC JS, Genero Web Client for JavaScript. You can run an application by changing the client down in the right-hand bottom corner to the web client. And then finally, exercise 4, you're going to write a simple BDL application just to try out your program blocks, variables, functions. You're going to work on it and run it, and then you're going to change it, run it again, and use a function the second time just to display your name.